So this video serves to go over the Chapter 12 IR Spec practice problems. So Chapter 12 is all about the infrared spectroscopy. IR determines functional groups present in a structure based off of their bond vibration frequencies. It is important to note we cannot determine the actual structure of our compound, but we can determine the functional groups. And that's exactly what we're going to do. So we have 11 IR spectrums and 11 compounds, and we're just going to match the correct structure with the correct spectrum. And we're going to do that by analyzing all of the possible bands that we can recognize. So starting with the first spectrum, the first band that should really be sticking out and that's really prominent, at least to me, is right here at 1700. We know at around 1700 we will have a carbonyl group. Whenever I do IR problems, I always look for 1700 because it kind of already helps us narrow down what our potential molecule could be, or what functional group we're looking for. We could be looking for a carboxylic acid, a ketone, an aldehyde, an ester, an amide. So looking at our 11 molecules, we have 1, 2, 3, and 4 molecules that have carbonyl groups. So that helps narrow down our options. If we continue to look and just analyze our graph, we have some alkane stretching right here around 2900. However, coming off of our 2900 stretch, we have this band right here at 2700. And this band at 2700 is going to be the carbon-hydrogen stretch that comes right off of our carbonyl group. So what we're really looking for is an aldehyde. If it was just a ketone, then we would not have the band around 2700. So that's how we know that this can't be our answer choice. If it was a carboxylic acid, then we would have a really broad stretch starting anywhere from 2500 going into the 3000, and it'd be really bumpy because it'd be mixed in with the alkane stretching. And then if we look at the last, so it can't be our carboxylic acid. And then if we look at this last structure down here, it's a carbonyl group, and then we've got an alcohol. This right here is not a carboxylic acid. It just contains a ketone and an alcohol. So if this structure were to be the first spectrum, then we would have to have a really broad band around 3300 to represent our alcohol. So that's how we can kind of prove all of these answer choices wrong. And that's how we know that this aldehyde corresponds with question 1. Now let's look at question 2. Question 2, we don't see a band around 1700, so we already used our aldehyde, but we know we're not looking for like a ketone or a carboxylic acid. However, what's really sticking out is this band right around 2200. So around 2200, we know that we have alkyne stretching. We know that this could be a carbon-carbon triple bond. And to confirm that this could be an alkyne, because we do have some alkane stretching over here, but our alkyne carbon-hydrogen stretching can be found around 3300. And that is what this band represents, right around 3300. we've got our carbon, hydrogen, alkane stretch. So now this really does confirm that for question 2, we're looking for an alkyne. And in all of our molecules, we only have one alkyne. So that would be our answer for question 2. Moving on to question 3. We've already used our aldehyde and our alkyne. So looking at question 3, we don't see any band around 1700, so we're not looking for a carbonyl group. We have some alkane stretching. However, what should really stick out in this graph are these 2 stiff double peaks right here. Anytime we have 2 stiff double peaks, we know that this is going to be a primary amine because it's within the 3300 to 3500 range. So what we should be looking for to match this spectrum is an amine, a primary amine. And again, we know it's a primary because we have 2 hydrogens, so it should be 2 peaks. If this was a secondary amine, where our nitrogen is only connected to 1 hydrogen, we would only have 1 stiff peak in the 3300 to 3500 wave area. But because it's a double peak, 2 hydrogens, primary amine, which leaves us with this compound as our answer. Now let's look at question 4. So question 4, we have a very, very, very prominent band around 1700. So again, this is going to be a carbonyl group that we're looking for. And this narrows down our answer to 3 compounds. We see this really, really broad band, and it's really bumpy as well. And it's ranging from about 2500 to about 3300. I know that this is going to be an alcohol that I'm looking at, and this alcohol is coming directly off of our carbonyl group. So what I should be looking for is a carboxylic acid. So this compound would be our answer to question 4. The reason why it would not be this bottom structure right here is because first, this is not a carboxylic acid. And carboxylic acids, the OH group ranges from 2500 to 3300, whereas just alcohols would be ranging from 3200 to 3600. So for this bottom structure, we would just see a really broad band right here, and then we'd be able to determine the alkane, or we'd be able to see the alkane stretching separately. But with a lot of our carboxylic acids, our alkane stretching is kind of going to be mixed in with that OH band. And so that's how we know that this is going to be a carboxylic acid and not our ketone and our alcohol. Looking at question 6, see, we've already used our aldehyde, amine, alkyne, our carboxylic acid. Okay, looking at question 5, we see this band that's right around 1600. So bands that are around 1600 are going to be our carbon-carbon double bond stretching. So that could leave us with either this alkene or this alkene. Now, if it were to be, we could kind of do process of elimination, because if we were to look at the alcohol containing, this is an aromatic, right? And if we were to have an OH group, then on our spectrum, we should see a broad band around our 3300 area. However, we do not see a broad band, so we know that an alcohol is not present in this structure. So that leaves us with just our 2-pentene. We see we have our alkane stretching, and then coming off our alkane stretching around 3100, we have our carbon-hydrogen alkene stretch. So that is how we could determine that 2-pentene is going to be our structure. Moving on to question 6. Here in question 6, what really sticks out to me, what I really see, is this broad band, ranging from around 3300 to 3500. I know beyond a shadow of a doubt that this right here is an alcohol. So that leaves us with either this compound right here, this compound, or this other compound. We've already used our carboxylic acid. So if it were to be our aromatic containing compound, we would expect to see a band around 1600. However, we do not have a band around 1600. So it cannot be our aromatic containing compound. If it were to be a mix of our ketone and our alcohol, then we should see a band around 1700 to be to represent our carbonyl group. But we do not have a band around 1700, so it cannot be this structure, which leaves us with just our propanol as our answer. We have our alkane stretching, and also to confirm that it would not be the aromatic containing compound, because we don't have any alkene carbon-hydrogen stretching. So that's just another way to confirm that propanol is going to be this structure that matches with this spectrum. Looking at question 7, one thing that really sticks out is our alkane stretching, but I don't see a band around 1700, so we don't have a carbonyl group. I don't see any stretching around 1600 or 2200, so this is not an alkene. This is not an alkyne. We've already used our alcohol, our amine, our triple bond, our aldehyde, our alkene, carboxylic acid. So that leaves us with, this is whenever we kind of just do a process of elimination. We already said there's no double bonds at all, so we could get rid of our aromatic containing compound. We can get rid of any structures that have carbonyl groups. And this really just leaves us with either a secondary amine or an ether. So if this structure, or if this spectrum were to be a secondary amine, we would see one single stiff peak around 3,300. However, we don't see that. So it can't be our secondary amine. To confirm that this is an ether, we would see a carbon-oxygen stretch around 1,000 to 1,150 wave numbers. So I know that's in the fingerprint region, but we definitely have this band that's around 1,150, which is our carbon-oxygen single bond stretch. And that's how I know that question 7 is going to be our diethyl ether. So sometimes you just have to do a process of elimination. Identify what you do have, and then with your structures, look at what you don't have. Like we don't have a band around 1,700, so we know that it's not a carbonyl group. We don't have a band around 1,600 or 2,200, so we know that it can't be an alkene or an alkyne. And then just kind of use what you have and what you don't have to rule out your compounds until you're left with what your correct structure is. So let's look at question 8. Question 8, we have some alkane stretching. And then we know that we're not looking for an alkyne or an alkene. We don't see a carbonyl group. We don't see a band around 1,700. Again, we could use process of elimination again. However, we have a single stiff peak around 3,300. It's not super prominent. It's not super obvious, or it's not as big as our double stiff peaks whenever we had our amine, right? This was very obvious. However, this single stiff peak, it's not as prominent, it's not as large, but this is still going to be an amine, specifically a secondary amine, because we only have one peak. That's going to be our one hydrogen. And the only structure that's a secondary amine is right here. And so that is the correct structure that corresponds with the this spectrum. Moving on to question 9. So the first thing that really sticks out is we do have a broad band over here. So this is going to be an OH group. We've already used our propanol. So that leaves us with our aromatic containing compound and then our ketone and alcohol. So we know that we would see aromatic carbon-carbon double bond stretching around 1600. And this lets me know right here that this is a carbon-carbon double bond, so it has to be our aromatic. If it was our ketone and alcohol containing compound, then we'd have a band at 1700. However, this is not 1700. This is 1600. So that would be our structure for question 9. Now, if we look at question 10, we see another broad peak. So this is going to be an OH group. And at this point, we've already used our propanol, our carboxylic acid, and then our aromatic containing compound. So through process of elimination, we could say that this would be our answer choice and we could move on. But to prove that this is our answer, here we could see the band at 1700. So this is our carbonyl group. And so if we actually go back and we compare question 4, which was our carboxylic acid, to question 10, because both of them have a carbonyl group and both of them have an alcohol. The only difference is whether our OH group is coming directly off of our carbonyl group or not. And in question 10, because our OH group is not coming directly off of our double bond, we see that we have a nice, smooth, broad peak where we can identify our OH group. And then separately, we can also identify our alkane stretching. Whereas if we were to go back to question 4, we have a really, really broad OH, a really broad band ranging from 2500 to 3300. And we can see how our alkane stretching, again, it's mixed in with that OH group. And so that's how we know that question 4 is a carboxylic acid. And question 10 is just 2 different functional groups, a ketone and an OH group. Looking at question 11, again, we could use process of elimination. We've used all of our structures except for our ketone. And to prove that this is a ketone, we see we have our stretch around 1700. So that's going to be our carbonyl group. We have some alkane stretching right here around 2900. And so that's how we could confirm that this is just a ketone. If it was an aldehyde, then we would have to have a little peak around 2700. If this was a carboxylic acid, then we would have to have a really broad stretch, broad and bumpy stretch from around 2500 to 3300, but we don't see that. And so that's how we know that the last question is just a ketone. So I hope that these practice problems were helpful. Continue to be familiar, memorize, and know all of the wave numbers associated with all of your functional groups, and continue to just do more practice problems. So this is going to conclude Chapter 12, Practice Problems. If you have any questions, please feel free to reach out to me.